So today we have a hard problem. Given string. About 300 letters. And we have a keyboard. With alphabet from A to Z. And this is 6 bits. So we want to find the shortest distance for travel on the keyboard. So if we have, and we have two fingers to travel. For example, one finger can be like this, the second finger can be like this, and they can travel some distances individually. So and this is obviously can overlap. So for example, for the word hello, and one finger can be like this, and the second finger can be for E and O only. So the problem is dynamic programming problem. Imagine we have some situation at some position, and depending on where we right now, the current moment, and what was our history or our future, so for example suffix of the string, we can define this problem as some addition to already known. This is a cached or memorized suffix, and the current would be some search. Take finger 1 or finger 2. This is a search, and obviously if we take finger 1, we have one story on dp, so this would be dp I plus 1 for finger 1 at some place, and for finger 2 it will be different story. This will be finger 2. Now the top-down solution is very simple. You just have to use these two fingers at, so this is a position on a keyboard for finger 1, finger 2. You have some state for define it by the current position and by finger 1, finger 2, and this is search for the next. Just compare if we want to use finger 1 or finger 2. So this is solution that is obvious and it is accepted, and this is what I would recommend because it is pretty straightforward. Now there is a exists a different kind of solution. If you look at the best, you can find some from Lee, for example, solution. I will try to explain how I understood it. So obviously I rewrote it for myself. Let's look at this. this is some crazy one. No, this is much simpler. But let's look at more obvious versions. Okay, this can be used. So this is a code, and solution is bottom up. And instead of using two fingers at once, we're using just a single finger at a time. And we at position I, the current letter is word I. And we know that we have to place some finger on this position. Place to this C. Obvious, and we know the previous like I would call it B before. So the previous would be VWI minus 1, and this is where our some other finger, so some finger we definitely have finger on this letter, on this. So we know that we have it. And now there is a decision if we move this from B to C, or if we have some other finger. So we have some other finger, and we don't know where it is, because the previous letter before this B can be tapped by the same finger, so we don't know where the other, but we can just find it, and we know what we want to find. So now this is some situation we have with position we have to place to. We know one finger, it is the previous position or previous letter, and we definitely have it, and we have some other finger, and we define our solution as the best previous position, that would save us, best to save us distance. And this is a search, and we define it as letter A, for example. So from A to Z we iterate in A, and the save is that we have a distance from distance from B to C. This distance, this is a given, and if we want to save, we are doing like the previous dp of A plus or minus the distance, I don't know what with my cable, minus distance from A to C. This is Okay, let's look at the code. Am I correct? Yes. So this is a search. We're looking for the best other finger savings, and there best previous savings minus current distance that other finger travels, and plus TBC. So we are saving us from traveling this distance. So T is for travel, and BC is what we would expect from the finger before. So this is a travel from BC, and if we want to save, we use this travel BC as what we are saved as. So if we found the other finger that can save us from traveling this distance, and now we are traveling, we have to travel the distance AC. The A is what we search from other finger, and minus because we are not saving, we're actually traveling it. And the previous best savings for this letter A from other finger. So this DP is the history of best savings, the entire path of best savings. And we don't have to memorize which finger does this savings, because at each situation, at each eye position, we can swap the finger between each other, because we can start with different fingers, so it doesn't matter which one. We know that we have a finger before that is definitely at position B, the previous chapter, and some other finger that we find that can save us some travel path, and we store it in a DP of the previous, not DP of current, this because okay, I forgot why we're saving it in on B instead of C, but this is just how it works, and it makes sense to store it on the previous. Actually, I would like to try to store it in DP of C. It obviously didn't work. Just let's try and make sure it didn't work. So actually it doesn't make sense, because we have this the B as our finger, the before finger before. It's not just some random finger. It is a finger of WI minus 1. So we store, we are calculating what would be the best to move this finger to C position or move some other finger. Let's just try C. I I'm sure this wouldn't work. Let's just try. Yes, it didn't work, obviously, because it doesn't make sense. But I can't explain. I forgot the reasoning. What was the reasoning behind it? There's some discussion on a Lee, and some people mention this part of why it is saving at B instead of C. So the final step is that we calculated this DP, and the entire DP would be 26 histories of savings, and we just have to use some maximum of DP, because we're only interested in the best successful savings. And then we use some we can use in the same loop, or we can use separate loop to calculate travel of the single finger. It is just sum of travel distance, and then we use dp max for max savings. Now let's look at this solution. I fold it in a single iteration loop. It looks pretty ugly. Let's look at different one. This one. So basically same with this next fold and two separate steps. The last solution is the same, purple windows, and it became pretty wide. I don't know how to make it shorter. Now it would be very good if I remember how to store what's the reason behind it. Maybe I'm just have a brain tumor at this point. So I explained this. We store the best traveling and the dp of A. So this is also crucial. Maybe this would be a hint why we're storing it in a B instead of C. So we're using dp of A, and those histories, they look like a linked list for we have some finger A, and it travels, and when we using travel to C from A, we have some history of previous dp of A, and the dp of A is a history of savings that ended with B on this ended finger on this A. So we have finger on A. So dp of A is when we have finger on A as a result. And when we doing this calculation, when we finding the best position to travel, we using this like comparing travel from the finger before B, and that means our B would be placed to the current position. B would be placed on current position C, and that means we have the same situation. So dp of A is when we have a finger placed on A as a end of this step. So that means when we have B place it on the current position, B finger, I would say, that means we have to use dp of B, as we do in this same situation, dp of C. So basically we have finger B, C, and when we go into the next step, the C became B. That means we have some dp of B. Finger on B. So it doesn't matter where this finger comes from B or from some other position, other finger A. It still goes to the C, and in the next iteration step, the C becomes B before. That's why we store this in a dpb. So I think I explained it. That's it for today.